Welcome to N is for Networking, the podcast where we make networking approachable and fun for college students, junior networkers, and anyone eager to learn the ropes. I'm Holly Metlitsky, a fresh voice in networking world, who's learning and growing together with our listeners. And alongside me is Ethan Banks, a seasoned network engineer who's seen it all. Today's episode is inspired by a listener who asked, why was the colon chosen as the delimiter for IPv6? To help us understand this, we have an awesome guest, Bob Hinden. Bob is a true pioneer in the networking world and one of the brilliant minds behind IPv6, the protocol that powers the modern internet. From his groundbreaking work at BBN, Sun Microsystems, and Nokia, to his leadership at IETF, Bob has shaped the way that networks operate and evolve. Whether you're curious about the history of the internet, want to learn how networking has transformed over the decades, or just want to know why the colon was chosen as the delimiter in IPv6, this episode is for you. So, thanks so much for joining us today, Bob. Before we dive straight into the topic, I'd love to get a bit of background into where the industry was in the 90s and how you landed up where we are today with the world of IPv6.
Okay. So I got really involved in networking. I started working for a company called Bolt Beranek and Newman BBN, who had built the ARPANET, and I got there in like 95, I think. Or wait, no, that's not right. 78. That was 95 was later. And so the ARPANET was going, and I did a little programming. I worked on, they had a multiprocessor called the Pluribus. I did a bunch of things there. I did a TCP/IP implementation for the Pluribus, for the Pluribus TAC, which was the terminal access controller. It was an ARPANET device that terminals connected, where you would type and usually have printers. This was before screens were popular or available. And so that's sort of what got me involved in IP and that. So I was one of the early TCP implementers, and this was particularly challenging because of the first one I did was on the hardware that ran the TAC or the TIP, which was like a 15-bit. A machine with 15-bit arithmetic, and trying to do 32-bit sequence number calculations on a 15-bit machine was we had to do all kinds of subroutines that could make it do that. So you couldn't just, add or compare numbers. So that was a little challenging, but we did get it to work. So and I got sort of from there, I got involved in what was sort of the early routers of the time. And we were basically, BBN had the contract with ARPA to basically run the backbone of the internet, which was initially was just a few networks sort of connected to the ARPANET. And so, we called them gateways then, but we now use the word router. And so I got involved in a lot of things, routing protocol. Well, basically, and then we did it's almost have to think about it that we actually did this. We actually, ran the core of the internet then. It wasn't very big, and, when it got to 100 networks, we thought it was really big. It's sort of by comparison, but I'm still sort of amazed that the hard problems we understood then, a lot of them are still the hard problems today. They weren't not solved because we didn't understand the problems. We just didn't know how to solve them in a reasonable way, especially given the technology we had that could be used. So that's what sort of got me involved in this. And I got involved in the organizations that involved into the IETF. And then in the IETF, I was I think I was the first area director for routing protocols. So a long time ago, I used to know something about routing protocols, but all of the BGP, OSPF, ISIS, those were all done. I was the area director. And then I got involved, we started to see that IPv4, or we just called it IP then, was going to run out of addresses. I think in hindsight, we were correct about that. I don't think we understood the timing very well. And that's one lesson I think I've learned is I really try not to make time predictions about when something will be done or transitioned or anything like that. The world changes in ways you can't imagine at the time.
So is that because of NAT, Bob? This extending the V4 timeline?
I think that was one of the elements. The other big thing that happened, the difference between, I left BBN, I think in 92, and went to work for Sun Microsystems. The thing that happened around then was the beginning of the commercialization of the internet. Because before that, it was just this, all these research networks connected together. There was no money. People were not making money. But with the creation of the web, that rapidly started to change. We saw the network grow immensely, and the focus became, how to grow and expand and make money. It wasn't before that. It was just technology. So, if there was a better idea, people would just do it. And so the internet world changed a lot. And I think that was maybe if we were a couple of years earlier, it would have all happened quicker. But, it happened the way it did. And I don't think that's something anyone really appreciated, in the folks in the ITF, which was also really small then, about how that was just going to affect everything. So I think that's what kept people were, should we work on converting to a new protocol, or should we grow our network to get more customers? It was a very simple calculation. And so it took a long time to get past that.
Interesting, because if you look at how things are now, I think IPv4 is still probably used much more widely than IPv6. So what do you think, outside of that difference between growing your network or making money versus moving to a new protocol, what do you think are still some of the biggest obstacles to moving to IPv6 when the broader adoption of it?
Well, so first of all, I think, from my point of view, looking at the Google and Facebook stats, they're seeing last time I looked, 45% of their access with IPv6. So that's getting pretty close to half.
Mm-hmm.
So I think it's, and that's a lot. And I unfortunately, don't have any data on this. I suspect, given that, a lot of video sites, like YouTube and Instagram and stuff, and so forth, I suspect there's more than half of the traffic, given use of IPv6 and video. And then there's a whole bunch of stuff happening sort of at the edges, with IoT stuff like Matter that, Apple and a bunch of companies are doing, Google, that's all IPv6. And that we don't even have any way of measuring. So my guess is we're actually further along than we think we are. But I think the biggest impediment is probably enterprises, because I think ISPs support it pretty widely, not in every country, not everywhere, but,
Tier 1s certainly do. Backbones certainly do. In North America, anyway, I find it's the regional carriers, the tier 2s and 3s, that may not support IPv6.
Right.
I still can't get it at my house as far as I know. Although I just had fiber pulled to my house and I have a new provider, so maybe they do. I got to call them up and ask.
Who's the provider?
My previous provider was Spectrum. Spectrum had consolidated, and they bought a bunch of networks, including the one supported up here. And I could not get residential V6. Business, maybe, I'm not sure, not residential. And Fidium is the current provider, and they're working with Consolidated Communications up in the northeast of the U.S. I don't know how big Consolidated's footprint is. And it never came up in the sales discussion, and I just got a call into support and say, hey, can we do V6? And see what they say. Haven't got there yet, but I'm going to have that conversation with them.
That's interesting. 'Cause, I mean, I used to have Comcast at home, and I now have AT&T fiber, and they just support it.
Yeah.
And so, when I go to a new place, I always check whether it's like we were in an Airbnb and sort of outside of Portland for Thanksgiving, and there was V6 in the house.
Well, and I'm on Verizon Wireless for my cellular service, and certainly that's V6 right to the handset, no problem. But yeah, so it's so what did they say?
Coming,
the future is here, but not evenly distributed. Yeah,
but it's not done. Yes, but I think that the biggest next step is enterprises. The activity in the ITF is, well, originally was called IPv6 only, but now it's called IPv6 mostly. So it's basically the notion. I take no credit for the names. But it's basically the notion that most of the things on your network can be IPv6, but there can still be translation at the edge to get to the things on the internet that are still IPv4. I think that's where the transition is going, where some Google is pushing this quite a lot. I think they're doing this internally, in their enterprise network. The ITF is been experimenting with it, and I think the plan is for the next ITF meeting, if the equipment will support it, will be to run the ITF network. The next meeting is like in March in Bangkok. Is to run in that mode where most things will be V6, and but you can still get to V4 things if you need to. And so that's where I think we're going. And that, I think, is the step. I think that's what enterprises will eventually do. But, this is not, necessarily their top priority. Otherwise, they would have done it. And so it's hard to figure out exactly what the incentive is.
Well, let me ask you a historical question then, going back to at the time that IPv6 was conceived, it was an addressing problem. We're going to run out of V4 addresses. You said that. Right. But it feels like as V6 was constructed, it wasn't merely let's extend the address space, but keep everything as it was in V4. Otherwise, there were all these other changes that went into the protocol, addressing a number of things that folks felt were shortcomings in V4. Is that a fair perspective? Is that kind of where your heads were at the time?
I think that's a fair perspective. Whether that was an overreach, I'm not quite sure. A lot of the things we did were good, but it is different. This is, the history of this. So first of all, I should mention Steve Deering, who's what I consider really the architect of IPv6. I worked very closely with him. We're co-authors on many of the documents, but he originally proposed it's a protocol called Simple IP, and there's now an RFC that documents what that proposal was, which had, bigger addresses, but not 128 bits. They were twice as big. And I thought it was a very nice design in that it kept the header size the same as V4, but had a much bigger address space and met all the ITF requirements for a new internet. And that would have worked, I think, a lot. That was going to be a lot closer to the way V4 worked. But the ITF, it's a standards committee, quotes around committee. And, people, they didn't want to do this again ever. So, whether those addresses were big enough, there was a big debate about fixed versus variable length. And, so that instead of I was never a fan of variable length because I think it just makes everything harder. It's a much.
But I think of that from a chip design perspective. Don't chip designers and coders really want a fixed length fields to work with? It makes things more predictable for them.
It's much simpler not having to always check the length, and and the experience of the time with another protocol that had variable length, the ISO connectionless network protocol had variable length addresses, but the way it was being used was at a fixed length. It was variable length, and it all had to be one size. So there wasn't really any operational practice for real variable length addressing. So at least that was my thinking. So the compromise was just to make them 128 bits were clearly long enough. That did give us the ability to do the kind of auto configuration that was easy, where you take your local token and you take the network prefix and you just stick them together and you have an address. It doesn't require a server. And so that was that was one of the big changes from before. You didn't require DHCP. You could still use it. And that's also been a debate in the ITEF forever.
Now you said local token. So for folks that are trying to picture this in their head, we had a 32-bit v4 address. We also would have had a MAC address maybe for Ethernet.
Right.
Are those what you're referring to when you say tokens?
Yeah, and that's how it's the original design basically used the MAC address as the token, because everyone had one, or almost everyone had one. You could still do other things. And that's how it started. So you basically took your MAC address, you concatenated it with the prefix you heard from the network, and then you had an address. And it's a very simple idea. It's very reliable. It works very well. We've evolved.
If you use the MAC address, guaranteed unique globally,
or as unique as it could be. Yes.
Yeah.
Right. Yes. There is no. You don't get perfect, but it was certainly good enough. A lot of things in network, the best is the enemy of the good. So there's never a perfect solution. So, but we've also, since for privacy reasons, evolved to just computing a random token. So it's harder to be tracked. It's not impossible to be tracked, but so that idea has evolved away from MAC addresses, but that's how they started, because everyone had one, and they were very, very close to being unique globally, so you could use them. So it worked. But our uniqueness requirement was really only for the link, so they didn't really even need to be that good.
You mentioned quite a bit there about it, and there's a lot of considerations that came into creating IPv6, but what would you say some of the biggest challenges you faced in the early development would be?
So I think we started out where everyone was very, this was still when, we'll build it, they'll use it, or, they'll come. And so that's where the ITEF was at that time. But, with the move to commercialization, we went through a period of time where there was sort of, I'd say, a loss of interest in the community. I mean, we kept working on it, and it didn't start to get a lot of uptake until people people who ran large networks had run out of v4 addresses, and they were having to use multiple levels of private addressing, and that was just very complicated and error prone. And so they were the ones who started moving towards running v6. I'm sort of Comcast comes to mind.
Folks using carrier grade NAT specifically, or other double NATed scenarios too?
No, basically instead of having to do NAT inside their network, I mean, they may still do NAT to the internet, but inside their network, it was expensive and error prone to sort of not have one global set of it, one address space that would work for your whole network. And so that's why we saw people like Comcast. We saw the wireless operators who were building very big networks start to do v6 inside their networks, and then of course if you're going to do it inside, then it's fairly straightforward to also let it go out, and that's what I think caused the v6 network to get to grow to the point where it's close to half of at least access to Google and Facebook and the like. So again, it was an address shortage. It wasn't the one we were thinking about, but some networks had basically grown out of V4.
What were the hardware manufacturers thinking about at that time? We went from 32-bit to 128-bit. And so from the standpoint of those folks making chips, manufacturing ASICs, was there a lot of input from them as far as V6 standards were developed?
Yeah, I mean, they were all involved in the IETF. I think it took them a while to be able to do for their silicon to get to the point where it could do wire speed V6, but that's been available now for a long time.
Yeah.
I don't even remember when, it didn't at this point exactly. Certainly not at the beginning. When we moved from software-based forwarding engines to hardware-based, and now the sort of the debate is how far. How many extension headers can they process at wire speed in hardware,
Yep.
or are they starting to look down into transport and or into the whole packet? And I don't have much visibility into what the capabilities are, but it seems to continue to grow.
It can be extraordinary, yeah. Holly, the show that we recorded, I think will come out after we publish this show. We were talking about how deep you could look into a packet for purposes of hashing for lags, for link aggregation groups. Yeah. Right. Bob, at least one more historical question on V6 here. Was there a V6 flag day ever considered where it's like, okay, we're going to drop V4, we're going to switch over to V6, we're going to throw the switch globally, and let's make this thing go? Was that ever discussed?
Wistfully, I think. I mean, I was at BBN when the NCP to TCP transition happened, but the only way that could happen is you have to have one person in charge. And in that case, it was the U.S. government, and they said, they said on this date you're going to turn off the old protocol and switch to the new protocol. And they did some test days and stuff, and they had the ability to basically, force that at a fairly low level. So you didn't have any, if you wanted to communicate, you had to transition. But there is, the good thing about the internet, I think, is there is no single entity in charge to do anything like that. So yes, it would have been nice in some ways as a forcing function, but there wasn't. That was the U.S. government was controlling this network in the U.S., but the internet was now worldwide, and there was no one. It had to be cooperative.
I worked for the state government for a number of years here in New Hampshire in the U.S. and remember some sort of a flag day that had something to do with DNS, I think. I don't remember what it was anymore. This goes back to the mid-late 90s probably. But just remember the news and the different posts that went out about this. And the internet was smaller then. It was but big and growing rapidly, but still small enough that there was that sense of community that if you wanted to do something like that, you could do it. You could get out there and do it. Now it is hard to imagine in 2024 that we could do such a thing. Right.
I agree.
One more kind of historical question that Ethan and I discussed. I'm not sure if you remember, Ethan, in one of our early episodes, somehow we stumbled into the idea that there was kind of discussion about IPv5 and got looked over, didn't really exist. What happened there, if anything?
Yes, that's a good. That question has come up a lot. So there was, there was the IPv4, and as you can guess, there were versions, some very early versions, 1, 2, and 3, which I don't even remember. That was before I got involved. I don't remember what they were. I think one of the early versions had the transport and the IP stuff all in one protocol. But so what was assigned the identifier value 5 was a protocol called Streams Protocol, ST, I think. And it wasn't intended as a replacement for IPv4 or IP at that time. It was basically doing real-time protocols. And it worked alongside V4, used V4 for management. And so it was never intended to be the next version of IP. It was just wanting to be able to send in parallel with IP. So that's how that version, that's where that version number came from. And they were doing audio and video, and it was pretty cool at the time.
Yeah. Yeah, there was the M-Bone. There was that whatever the predecessors
the
to
M-Bone was
RTSP
multicast.
were.
So that was V4 multicast, and then eventually V6. But Streams was actually
global
before,
or intended to be global, if I recall.
Yes.
And for purposes, and that was one of the considered use cases was streaming protocols.
Right.
Yeah.
All right, then I think we should. You got another one, Ethan?
Well, I'm still waiting for you to ask about the colons.
We're getting there.
We're getting there.
Well, Bob, we have this opportunity to pick your brain, and this is a great conversation.
It was more fun than talking about colons.
But so there was a recent proposal within the last, 3-ish years in the IETF about IP version 10, which went nowhere. It had its shortcomings and so on. But I was wondering if you were aware of that proposal, if you kind of remember what the intent of it was. And it was designed to help with backwards compatibility with V4 and, in theory, hasten V6 adoption, if I recall. But do you remember that proposal, and had any thoughts about it?
It seems to show up periodically. I haven't looked at it very closely. My take is, it had a bunch of claims for what it wanted to do, but then if you actually looked at what was written, it didn't seem to match very well to me. So I didn't spend a lot of time looking at it. But the author, the nice thing about the IETF is it's very easy to propose something new. It's much harder to get it standardized or published, in an RFC. So we may see it again, but I think it's I didn't see anything that was particularly new or useful when I looked at it.
I mean, this is not my area of expertise, but I was at an IETF meeting when this was proposed from the gentleman who was behind it. I think he was coming from the other side of the planet from where the IETF meeting was happening, and his connection was unstable. So it was difficult to get.
We did try to give him a speaking slot, and it didn't seem to work out.
Yeah. But right, it went nowhere, and I guess there's reasons for that. Well, Holly, maybe you should ask Bob the.
Well, I have one related thing. So early on, there were a number of other proposals, but I think my favorite was called IP version 16, which I found quite interesting because it's a 4-bit version number, and you can have 0 through 15, but you can't have 16. So it sort of was a little weak on the technical side.
Okay. Well, Holly, it's probably time for us to ask Bob the whole reason we invited him here.
Yes. I think just a little bit of background for our listeners. I know we haven't done an IPv4 episode just yet, and we've spoken a lot about it. But leading into the question, one key thing to note, if you haven't dealt with IPv4, is that a dot separates the 4 octets in the address. So this standardization is what leads to the question that how did we get to the colon? And this dot or the colon is also referred to as a delimiter. So now, looking at IPv6, a colon is used. And since we're all used to IPv4, the colon can take some time getting used to, leading to the listener's question. And so instead of speculating and Ethan and I sitting here saying, well, maybe it was this, maybe it was that, why not ask the expert himself? So could you give us some insight into the colon, and were there any other options considered perhaps?
Well, I think it did get a lot of discussion. I went back and looked at some of the early documents, and so it's always been a colon. And some of the reasons why we did this, though I admit to not remembering all of the discussion, was, I mean, we definitely didn't want it to look like V4. I mean, V4, has, uses the dot, but the numbers are decimal numbers, which is a really was sort of made sense before we started doing subnetting, because having to so that's what, when we decided to use hex, because it was a lot more compact, but it's a lot easier to look at a hex number, a 4-digit hex number, and see what the subnet boundary is, because it's, it's a very straightforward turning it into binary, which is what sub. So if like a /48, you can see where that is in the address hierarchy, or /50 or whatever. Where if it's in a decimal, I'm really amazed that people got used to dealing with the decimal numbers in V4, because it's a really terrible design.
I'm laughing because so many networking students have beat themselves up trying to get their heads around how to do V4 subnetting because of the difficulty of translating from decimal to binary, which is really what you need to do to be effective and understand it.
I am one of them. I watched countless videos and did a bunch of practice on it to try and figure out, okay, well, where in my zeros and ones, where's the network address ending and where is the rest beginning? And it caused a bit of headache.
And that's the history of that. It is, as I remember it, is that, I mean, we originally started out with these class A, B, and C addresses. So the boundaries were on the, the 8-bit things. And so that wasn't so bad. But when we started doing variable and subnets, it's just a giant mess. And people got used to it, but you sort of need to look it up in a table, and people got used to the numbers, but it was really, in hindsight, in my opinion, a terrible design. So the use of, could have been octal, I guess, but that would have been long for V6. But so the use of hex, I think, actually makes it a lot simpler. But the other general thing is, because these addresses were going to be big, and especially, they weren't meant to be easy to type. We were not trying to optimize that. We assume you would use DNS or some other naming system. And so we wanted having some sort of delimiter was useful. We didn't want period, because that made it look like V4, and we didn't want any confusion there. And then in some ways, there's either a lot of choices or not very many choices, because different characters get used in different things. So, I think Steve Gehring came up with the colon, and it's back in the first. We wrote a white paper on SIP. That was the oldest RFC I could find, and that had colons in it. And so I don't think there was no one ever proposed something that we thought, or the community thought, was a lot better. So I think we just stayed with the colon.
But the biggest reason you ended up with a colon, you definitely wanted a distinction between V4 delimiters and V6 delimiters. So that just took dot off the table, even though the rest of the V6 address would be clearly distinct.
Right. But you would, well, and because there was I don't think they get used really now, but there was also a format that actually combined the hex and with a V4 address at the end, and so you wouldn't be able to do that.
I was going to ask you about that. Yeah,
that turned out, I think, not to be that useful. But there were a lot of ideas tried out. So having something different, I think, was useful. But because also, you didn't want that. You just wanted to make it very clear what kind of address it was, besides the length. So I think you could just say that the colon is really just 2 dots if you look at them vertically.
That is true.
Yeah.
I'm thinking of it now. I don't actually know what options I'd suggest. I wouldn't give you a comma because a comma is similar to a dot. And why would you go for a semicolon? Because you could just do a colon. So it is kind of that. You wouldn't want a slash because that really you would think about subnetting. So very quickly you start running out of options. Maybe a dash.
Hyphens or dashes come up. Yeah.
Right. I mean, then it's just you get something that's different. And I don't, again, as I remember, I don't think we ever found anything that was significant. Everything had pluses and minuses. So we stayed with this, and it seems to have worked.
And then I guess the colon, you've got some shortening methods where if you have some repeated addressing, then you can have like two colons next to each other. And I mean, I learned about this a while ago. Yes. Did that come into consideration with the delimiter, or was that just...
I think that was just, using two of the delimiters to indicate a series of zeros. So if it was a different character, we would have done the same thing.
Mm-hmm.
I don't think that would have made any difference.
Now, you mentioned the assumption was no humans typing these addresses out by hand. That's
not very often anyway. Yeah.
And do you think that's proven to be true, predominantly the way it happens? And it's mostly just the occasional network engineer who's stuck trying to type out this long address by hand with hex and colons?
I think that's mostly true. And then it's even probably, if you are having to enter them, you may be copying and pasting a lot. Yeah. And especially if you're picking up, the random ID and seeing a prefix, and I think this is just for network engineers. You're probably not going to actually type one into a web browser. You're going to maybe paste one in, but you're not going to type one in. Or at least I don't think I've ever had to do that, other than maybe loopback or something like that.
Yeah, our listener who proposed this question seemed to be typing them a lot. So
that's interesting. Maybe the question is why.
Yeah.
I'd be curious to know why he or she is doing that.
Yeah, it gives us a good look on it. I mean, it makes a lot of sense now. I honestly quite like the colon. Never thought about it until our listener posed that question, but it's a good discussion to have, and it looks good and it looks different. So
yeah,
I
think it's worked out fine. And looking at my keyboard, I mean, you do have to press Shift to get it, at least on my keyboard. But other than that, seems fine to me.
Yeah. So Bob, looking back at your career, what stands out as the most significant evolution in networking technology, if you can pick one?
Oh, that's a good question. I think it's that I think I and everyone else, involved in the early internet, are really amazed at what's happened and how large and broad and central to everything these days, maybe too central, the internet has become. And I don't, it started out as this research project and it was growing, but then, with the web and, it just really has changed the world, in many ways. I think we were also surprised that we were thinking that it was going to be the majority for good, and for to allow that it was good to allow people to communicate. Of course, then some people decided maybe we don't want people to communicate, and then we were not thinking it also gets used for bad things a lot, and so I think that's I think we didn't appreciate that. I don't know if anything different would have happened. As it said in the beginning, we understood a lot of the hard problems were, and I use a very broad "we" in that. And there were papers written, there were solutions, but there weren't there weren't things that could be implemented easily or well, or again, trying to make it perfect, it wouldn't have happened. And so I think that's the sort of the good and the bad here is, we see the internet used for bad things, ranging from people being defrauded to or much worse things, but we also seeing it being used, so it does allow people to communicate, mostly for useful things, but the government, some governments of the world decided maybe that's not a good idea. So there will always be a big tension there.
When I was first doing networking back in, again, the 90s, when it was mostly LANs and the client server revolution was taking over, the networks were internal to a campus and so on, and we had leased WAN lines, and the internet was like this extra foreign sort of thing. And if you were foregoing a dedicated WAN circuit and using a VPN tunnel to connect two sites, for example, it was like, we'll do it because it's cheap, but we don't want to have to count on it. It's not, we wouldn't consider it a lot reliable. Now let's contrast that with yesterday. I'm headed down to Boston to meet some folks, and I spent much of that trip in a bus that had Wi-Fi, and I believe it was gateway through terrestrial cell networks. So that, and I was working on a server on the bus from my laptop using that Wi-Fi with an SSH session and Zero Tier, a product that's doing some tunneling and relaying to allow the connectivity between that server and my laptop across a public space without me having to use a VPN. It's a different sort of VPN, I guess. And you know what? It just worked. I mean, we had wildly different latency profiles as we were, skipping from cell to cell, but unbelievably, I never lost my connection. And was able to do quite a bit of work while reading documentation from other internet-based sites while cruising down the highway in a bus. I mean, that is where we've gotten, and that was unthinkable not all that long ago, Bob. So, I mean, you talked about how much we rely on the internet now. Yeah, I was at a company not that long ago that was doing payment services, and we offered many payment gateways and payment APIs via the internet. You could consume them, and that was expected to be reliable. It was not a take a chance. It was like, no, real-time payments were happening across the internet, and this goes back a decade. So the evolution has really been something.
It's like electricity.
I mean, I've grown up in the world of internet. I can't quite imagine my life or career or anything without it. I mean, I haven't had a moment without it my entire life, it's crazy.
Right. And you assume, Holly, that it works, that it just works.
100%. I mean, until I got into networking, it was just the internet, and that was it. There was no questions asked. It just worked all the time. And if it didn't, well, that was disappointing, but no problems, because it would get back up, and exactly like you said, like electricity. It's
right. Well, and now you have your maybe your home network, and then you have your cell phone, and one doesn't work, the other may work, and there's always an option. We have redundancy. Yeah.
Yet another example of that. I live in a rural mountain town. Someone took out a telephone pole on a major route up the street that happened to take out a piece of fiber that took out regionally a pretty significant amount of internet. A lot of restaurants and other small businesses closed their doors because they couldn't process payments because the internet was out, unless maybe they had cellular as a backup, because that was the only other option.
And who takes cash anymore?
Yeah, I was going to say.
Right? It's so definitely woven into our...
we have things like Starlink, so you can now get, much faster, high quality internet pretty much anywhere. If you can get the hardware, and you need power to run it. But that's I'm involved in the sailboat race from San Francisco to Hawaii, and we're the cheaper version of Starlink just started just before the last race, so some people did it, but I suspect in the next race in 2016, probably the majority of the fleet will have it. Everyone's going to have high-speed internet.
Yeah, sailing across the ocean.
Yeah, the challenge will be to get the crew to off watch to go to sleep as opposed to watching YouTube.
Yeah.
Wasn't
So,
an
Bob,
issue
what's
before.
is a good closing question for you? What's a piece of advice or an insight that you wish you'd known when you started your career?
Well, I think, well, when I started my career, this, communication was just getting a line between two different computers, and all the protocols were proprietary and stuff. So, for me, the big evolution was, getting to work on the thing that, I was just sort of in the right place at the right time to get involved in the early internet. And, I didn't know what, when I went to BBN where it happened, had no idea. But, it sort of was a really the right time, the right place with the right people, I guess. So that was really neat. So I'm really, curious as where this will continue to go. I hope we can solve some of the hard problems, and make it, some of the bad things less bad. So the world is pretty complicated, but, but I think it has at least become something that everyone relies on, and that's mostly a good thing. So still overall, I think we did a good thing. I don't think the bad outweighs the good. But it's there are certainly challenges that were discovered or created that we didn't understand. But I've been very fortunate and lucky to have been involved in this for such a long time, and I still try to stay involved. But so it's been very gratifying for me.
Yeah, I hope, as someone who's, I guess, possibly in the right place at the right time, maybe, I hope that one day in 30, 40 years time, I can look back and I also have all these cool things to share about where we are now and where we'll be and how everything's changed. It would be fun. So
yeah, and I think that, the advice is that, if you have an idea and you think it's important, keep working on it. A lot of people will say, it's not good or it can't happen, but, keep at it. Nothing worthwhile is ever easy. And so that kept us going a lot. There are a lot of naysayers about V6, we don't need it. Didn't happen for a long time. That seems to have stopped. And so, just keep working on it, build a community around what you're doing, you can't do everything yourself, try to get other people involved, and just keep at it. And, some luck, you may be solving a problem that's important for a lot of people.
I think that's a great piece of advice to close with. So, Bob, thank you so much for joining us today and taking the time, sharing your expertise and stories. It's been awesome. It was truly an honor to learn from you and one of the key figures in the evolution of the internet as we know it. And it's not every day that you get to chat to someone who shaped such a fundamental piece of networking, from the history of IPv6 to the maybe surprising for some role of the colon. This conversation has been enlightening and inspiring. So, yeah.
Well, thank you.
Yeah.
Thank you for having me. I enjoyed talking.
Of course.
Thanks for making the time, Bob. Yeah.
Yeah, it's really a pleasure. And thank you to our listeners for tuning in and proposing the question. If you've enjoyed this episode today, please subscribe, leave us a review, and share it with your fellow networkers. You can connect with us on LinkedIn, and our links will be on packetpushers.net/hosts. Bob, where can our listeners find you?
Probably by email in the IETF. I guess I have Facebook and Instagram and LinkedIn, as does everyone else.
Okay, perfect. Then find all of us. I think LinkedIn is usually the go-to, so that's perfect. And if you've got a burning question or any more topic suggestions, send it our way at packetpushers.net/follow-up. We might just feature it in a future episode. So until next time, keep learning, keep networking, and remember, networking isn't hard. Other people figured it out, so you can too.